Hi, welcome to day 15 of our series on Common Lisp. So today we'll be continuing our journey with my toy Grep. Let me go back to the code. Now there are different things I've done here, but I'm going to go out of order and talk specifically about one concept today, which is managing command line arguments. So if you see here, the very second commit I've done is to add some kind of basic command line args, and I've done something very simple here. I am using UIOP, which is like a library of some common utilities, and here I have used UIOP command line arguments. So just calling this function gives you the list of arguments that you have passed from the command line. So this is how I am checking the arguments here. So if I just run, you see that I need these two arguments and I can just pass them as strings like I just did here, right? So this is how I'm managing the very first version of arguments. And then if you see my code, I then do some extra validation of the argument. So let's see what I've done here. I have taken the args as a list and then taken the length of the list. And firstly, I'm checking if the length is exactly between 0 and 2. If it's not, then it's incorrect number of arguments. And here I've used the return from for. So this is yet another open design choice that you have. One option is to just do an if else and then continue on what you want to do in the else branch. Maybe that's the cleaner option that is normally preferred. The other option is this early return, right? So I have this condition, and if it's true, I just want to return from then and there. So the format here is return from name of the function and then the value that you want to return. So it's not very as simple as a simple return. So for example, you need to give the name of the function, which is not great, right? What if you change the function name later? So I don't know if this is the best way to do it, but that's what I've gone with. And obviously I'm not returning anything because it's my main function. And now if you see, I've also used the when form. So I don't really recall if we discussed when earlier. So the idea of when is if you use a if form instead, so what you get is the expressions after that. The first expression is the positive case and then the next expression is the negative case, right? So it's very easy to make a mistake if you want to do multiple things in your body of if and you have to put a prog in. So instead of that, you can use a when form. So basically I'm not really caring about the else condition here. I'm doing when of the condition, and then the rest of the forms will be executed one after the other. So that's the advantage of the when form. And once you've done this, I then parse out the arguments to get the second. Here I have just left that the second argument is optional. If it's not passed, I will just take the current directory. So that is the idea, because I think Grep does something like that. And again, if there is some problem, I just do your thing, right? So basically print out that something is wrong and so on. So I think maybe again this code is wrong. Maybe there should be a return from here. But yeah, that's okay. And then finally, you're going to launch the actual function with the string and directory. So this entire function is just a wrapper to manage your argument. So if you go back to my commit log, you will see that then the rest of the code here, I have just gone deeper into the functionality of Grep. I will discuss that in the next video of how we are doing this, what's the architecture. But in this session, let's continue to look at managing these arguments. Towards the end, after a lot of functionality, I wanted to add flags, right? And basically flags to control if some particular value or set some particular, for instance, I have a flag to set the number of threads to control parallelism of my grep, right? So I want to be able to set that from the command line, and this simple approach of just getting argv is not going to work. We need an actual library to parse flags and arguments and so on. So I've actually added this functionality quite late, right? You see here, like towards the end, I've added this. Till then, I just hard coded in my code the parameter and just went with it, right? So that's just architectural choice, but we'll cover this also today. So essentially here I have done some things. I will show you what I have done, but we have based our processing now on a new library that we're using, which is basically we're taking the raw arguments and we are going to pass that into our Unix options library. So let's look at that library. So if you see here, I have added that as dependency. This is a new library we're going to use. Now, there are different libraries to do CLI parsing. There are actually quite a few. If you search, you'll get different options. I just wanted something light, so I've gone with Unix opts. So the documentation of the library is here. It's very, I mean, if you've done arg parsing and flag parsing in other languages, it's very similar. The core concept is the same. You have to define some options and some parameters for those, and then you let the system parse it, right? So if you just see my code here, ignore the other things, but here I have actually defined the ops that we'll use and how to process those options. So if you see in the main, we no longer, we basically take the args from the command line, so we still take that, and then we pass that as the argument for the process options. So this process option is a function you see here, and let's take a look at that. I have based my example both on the documentation here of Unix opts, but also the actual example that they gave in their repo. So this is the Unix opts library, and there is an example file, and there is this Lisp file that basically talks about, gives you some sample code. So in action, what I mean is this sort of thing will now work. If you see here, I have to set the number of jobs, like that's my flag. If I remove this, it will throw some error because that didn't work. Now I didn't catch this error properly. That's why this is a common Lisp condition that has been raised, and it throws you into the REPL. That's fine. It depends on what you want to do. Do you want to expose this to the end user? Like say, for example, because this is common Lisp condition system, I can say skip the option, right? And it will continue and it will still work. So that's great. But if maybe that's not what you want, right? Maybe you want to do something different. Maybe you want to capture that error and like throw it in a very standard Unix style to the user. So that's why this example actually talks about dealing with unknown options, and it's basically wrapping conditions. So if you see here, this is the way this is done. So there is an handler case. So this is how you can basically deal with errors in your actual function. So this portion is the one that will be run. And if there are some cases thrown from this portion, you can basically catch them here, catch those conditions and deal with them and do whatever it is that you want, right? So I didn't do that. I took a very simple option. Well, there is one more thing to note here. If you see, if I do this, which is very standard syntax in almost all Unix tools, this doesn't work because it thinks this as the way to as the list and not separated out. So I didn't find a solution for this yet. This is not good. We would like a library that actually deals with this kind of J4 correctly. But for the moment, we will just use this attack. So instead of this, I can just do this, and that is run with 8 threads instead of 4. So for now, this works, right? If I open the options file where I define my options, so like before, this options is yet another file, but it's part of the same package, so it's not a different package. Now this is the core portion where we basically define our options, right? And maybe it's worth looking at it once. So we have the syntax where you need to specify each of your options, and your first option here I have a name called num workers. That's the one we saw. It has a description, and it has a short flag with slash the character J. That's what we used. It also has a long flag. So if you use jobs, so most likely if I go back and instead of doing this, if I do this, sorry, this will work in the same way, right? So that's the idea of this long flag. And if you see this arg parser, now this is important because this is indicating that there is an argument for this flag. So for this J flag, we have one argument that follows it, and we expect to pass that string, convert that string into an integer. So that's why we pass this function as your arg parser. If you do something else, if you are expecting something like Boolean or something else, you can write your own function and link it up here. And this metavar is basically used to control what value shows up in your documentation in the help doc, right? Now, the reason for bringing this up is the next flag. If you look at the next flag, it's very similar. It has a name, it has a description, and it has a short flag, it has a long flag, but it doesn't have arg parser, right? It doesn't have any arg parser. That's because this is like just a toggle flag. So it's present or it's not present. So when you dash M, it enables a different code path. In my case, to enable mmap based file processing or not. Right? It doesn't actually have any argument that follows it. So this is useful for controlling what the flag should be. The chunk size flag here is actually very similar to the first one, so there's not much of a difference. There are more features. I recommend going through this tutorial and seeing all of the features, the other options. And if you see here, I have defined the options, and then I have come to my actual process options function. So let's talk about this, right? So it's getting a single argument, which is a list of whatever is passed in from argv. So this is that list, and we're going to do something here, and we're going to return something back, right? So the core thing here, let's focus on this, the middle portion, the handler case. So this is the core portion. So like I mentioned, let's talk about what this is doing. So this is handler case followed by the main code that I want to run. And what I want to do is I want to actually parse the argument. So get opts of my input, right? So that's the syntax. That's the way you use this library, right? So once I do this, this is going to try to parse this thing. And if you see, it's basically going to it might have problems, right? For example, there's an unknown option. So let's try that and you'll understand what I mean. If I have a different flag like L, which doesn't exist, you see it's not gone to the condition system. It's instead printing this and just stop, right? So how did this happen? Because I have caught this, so to speak. This is exactly the condition system in Common Lisp is a more advanced version of the try catch or exception system you have in other languages. So this is exactly that. This is like a try catch, and you are catching this condition, which is ops unknown option, and the condition itself object is in C, and then I can do something with that, right? So in this case, I have said that I've used the ops option of C to actually print out that this is the option that was unrecognized. And opts, the library also has this nice exit one, uh, basically function to directly exit. So I've just used it, and that will just cleanly exit out of this location. So now this is the core, like this is the portion that you just see here, right? So that's great. But then what? So what am I doing here? So then the thing to focus on is multiple value bind. So this looks a bit like let, but it's not, because this function here, getOpts, actually returns multiple values. So this is yet another thing in Common Lisp where you can have more than one return value. And if you want to actually catch them and use them, so in some kind of like destructuring, so to speak, you basically use multiple value bind. And what we're saying is the first return value from this core, this body, is going to get stored in options, and the second return value is going to get stored in this other thing called free args. And the reason for this is, like this documentation says somewhere, idea is anything that is left at the end, not the options, but the arguments, like the name of the file, name of the folder, or the string. Those are the arguments at the very end, which will just be returned, right? So because I already had the logic to deal with those, and those are not flags, not options, but arguments, I will just, you continue to use that code. So that's why you see I return the free argument as the very last thing here. So basically what I'm going to do is I'm going to run this code body. I'm going to take out the options and the free arguments. I'm going to return the free arguments in the end. But before that, I will do something with those options, right? So I will use those options to change how my core code works. Now you can do it in different ways. In my version, I have basically used global variables, a bunch of parameters. So this plus that you see here is a standard convention for parameters. So I have done def parameter, and then I just set the global variable, and then I'm done, right? So that's how I can do. I can set the global variable from here, and that's enough. The rest of my program will refer to these variables and use the right value. So how do you use an option? For the moment, just look at this example. Basically, we have the options object, and we have used getF options of the name of the option. So the name of the option is what we defined here. So if you see the num workers, mmap, and so on. So here I have the name. So if you just look at this code, what I'm doing here, I'm just checking. I'm taking the I'm checking if the option exists, as in I'm just checking if it's true, and then I'm doing something, right? I'm taking some action. So if you go back to my code here, you will see how I the code I had here initially, for example, to set the number of jobs flag. If I have that as a flag, because these are optional flags, right? I have not set any of these as required flags. It will work without these flags. So it will have some default values. So if that flag exists, I'm then going to set the number to the value of that flag, right? So that's what we have done. So this is basic argument parsing. You see here in this example, they have more conditions that they catch. For example, if there is a missing argument in case of a compulsory argument, or if there is some other failure in parsing, like you saw when I did the J, and so on and so forth, right? So you can basically catch whatever conditions are make sense to you, and then you can deal with them however you want. Like you can basically even continue processing, like ignoring it. If you see here, that's how they define this function to basically restart by just ignoring that portion. We'll talk more about the condition system later. So for now, this is a way for you to skip things or just exit out of your processing or just leave it. It's fine. But this is your basic argument parsing logic.